Imagine a building so tall it would pierce the clouds, dwarf every skyscraper ever constructed, and function as a vertical city for 100,000 people. Not a fantasy from a sci-fi movie, but a fully designed, mathematically engineered structure planned to rise 1,128 meters into the sky. It was called the Bionic Tower, and decades later, no one has dared to build anything like it again. Not because it was impossible, but because it may have been too far ahead of its time. The Bionic Tower was conceived by Spanish architect Eloy Celaya in the late 1990s, long before supertall skyscrapers became symbols of national power or national pride. At the time, the tallest buildings on Earth were barely half of its proposed height, and even those were considered extreme. Yet Celaya wasn't chasing records or headlines. He was focused on a problem humanity still hasn't solved: how to house massive, growing populations without consuming endless land, straining infrastructure, or destroying surrounding ecosystems. His solution was radical in both scale and philosophy: compress an entire city into a single vertical structure. Homes, offices, hospitals, schools, parks, transport systems, even food production would coexist inside one self-contained megastructure. The tower wasn't designed to dominate a skyline or serve as a monument to power. It was envisioned as a replacement for horizontal urban sprawl itself, a city folded upward rather than spread outward. What truly set the Bionic Tower apart wasn't its record-breaking height, it was how the structure was meant to survive it. Rather than relying on rigid, overbuilt frameworks, the tower borrowed its core principles directly from biology, treating the building less like a static object and more like a living system. Like the human spine, the structure was designed to be flexible, segmented, and adaptive. Its form widened at the base and tapered as it rose, distributing stress the way bones and muscles naturally carry weight. Internal structural rings acted like vertebrae, absorbing movement caused by wind, seismic activity, and temperature shifts instead of resisting them outright. This approach wasn't brute force engineering. It was bio-inspired design applied to architecture, decades before such thinking became common in modern construction. At heights approaching 1,128 meters, gravity isn't the primary enemy, wind is. Air currents at those elevations behave unpredictably, generating forces that can destabilize even the strongest structures. Traditional skyscrapers are designed to fight wind. The Bionic Tower instead was designed to cooperate with it. Its aerodynamic shape reduced vortex shedding, while advanced internal damping systems were planned to absorb oscillations before they could amplify into dangerous movement. Multiple sky lobbies divided the tower into vertical neighborhoods, limiting elevator travel distances while also breaking up structural loads. Beneath it all, the foundation was engineered as a massive anchor, driven deep into bedrock and spread across an enormous base, capable of distributing forces never encountered by conventional buildings. On paper, the physics worked, the equations balanced, the simulations held, and that mathematical certainty is what made the project feel so unsettling, because it suggested the impossible might actually be achievable. The Bionic Tower wasn't meant to be visited or admired from a distance. It was meant to be lived in. Designed to house up to 100,000 residents, it functioned as a fully self-contained ecosystem rather than a traditional building. Residential zones were stacked above commercial districts, creating layered neighborhoods instead of floors. Green spaces and artificial parks were embedded throughout the structure to provide natural light, airflow, and psychological relief. High-speed elevators weren't just transportation. They functioned as vertical metro lines, moving people between zones the way subways move through cities. Energy systems combined wind turbines, solar collection, and closed-loop recycling to minimize waste and external dependence. Even emergency scenarios were deeply modeled. Segmented fire zones, independent life support systems, and multiple redundant escape routes ensured that no single failure could compromise the entire structure. This wasn't just tall architecture, it was urban planning, rewritten in 3 dimensions. So why did a project with viable engineering, detailed planning, and global attention never rise from the ground? The answer wasn't technology, it was risk. No private developer wanted to be the first to gamble tens of billions on something humanity had never attempted. Governments feared the political fallout if the project stalled or failed. Insurance companies refused to underwrite a structure without historical precedent. And construction firms quietly acknowledged that while the design was sound, executing it would require precision, coordination, and logistics on a scale the industry had never experienced. In short, the tower wasn't rejected because it couldn't stand. It was rejected because failure would be catastrophic. Beyond engineering, critics raised deeper and more unsettling concerns. What happens when an entire city depends on a single structure? How do people psychologically cope with living hundreds, even thousands of meters above ground for decades? And if systems fail, power, water, evacuation, how quickly could recovery happen? Others questioned inequality. A vertical city could easily become a vertical hierarchy, where sunlight, air quality, and social status rise with elevation. Environmentalists warned that concentrating so many people into one megastructure might amplify disaster scenarios rather than reduce them. The Bionic Tower wasn't just an engineering challenge. It was a social experiment humanity wasn't ready to test. Here's the irony. The world is now facing the exact problems the Bionic Tower was designed to solve. Cities are running out of land, housing crises are intensifying, urban sprawl continues to destroy ecosystems, climate pressure is forcing density, not expansion, and suddenly vertical megastructures no longer sound absurd. They sound inevitable. Modern projects like The Line, arcology concepts, and vertical city experiments echo the same ideas. But none approach the scale, integration, or biological intelligence of the Bionic Tower. It remains unmatched, unbuilt, and quietly influential, a vision waiting for a world bold enough or desperate enough to finally attempt it. The Bionic Tower didn't fail because it was impossible. It failed because it exposed something uncomfortable. Engineering can move faster than society's courage. Even today, with stronger materials, smarter AI, and better construction tools, no one has dared to attempt what was already designed decades ago. The tower still stands, not in steel and concrete, but as a reminder that the future isn't limited by physics alone. Some ideas don't disappear, they wait, and when the world finally runs out of ground, the Bionic Tower may no longer look impossible and only inevitable.